My Safety Training Online presents the basics of electricity safety. Welcome. What you will learn. We'll discuss the physics of electricity, its definitions, the body and electricity, how burns occur, power lines and electricity safety, cranes and power lines, ground fault circuit interrupters, and how electricity kills, along with using your power tools correctly, proper grounding, and abuse of power tools. Basics of electricity, the physics. Operating an electrical switch is like turning on a water faucet. Behind the faucet or switch, there is a source of water or electricity, a way to transport it, and pressure to make it flow. Three factors determine the resistance of a substance to the flow of electricity: what it's made of, its size, and its temperature. Here we can see a diagram of the physics of electricity, showing the transmission line, disconnect switches, circuit breakers, and a transformer. Substances with very little resistance to the flow of electrical current are called conductors. Examples of this are metals. Substances with high resistance that they can be used to prevent the flow of electric current are called insulators. Examples of this are glass, porcelain, plastic, and dry wood. Electricity travels through closed circuits, normally through a conductor. Shock results when the body becomes part of the electrical circuit. The current enters the body at one point and leaves at another. Three primary factors affect the severity of the shock a person receives when they are part of an electrical current. The amount of current flowing through the body, measured in amperes, the path of the current through the body, and the length of time the body is in the circuit. 1 milliamps will give you a perception level, a slight tingling sensation. 5 milliamps will give you a slight shock, which is not painful but disturbing. 6 to 30 milliamps will give you a painful shock and muscular control is lost. At 50 to 150 milliamps, you'll be in extreme pain along with respiratory arrest, severe muscular contractions. Death is possible at this particular level. Between 1,000 and 4,300 milliamps, you will experience ventricular fibrillation, muscular contraction, and death is most likely. 10,000 milliamps, cardiac arrest and severe burns, probable death. Shock-related injuries include burns, internal injuries, and injuries due to involuntary muscle contraction. Burns are the most common, of course. Thermal contact, flash burns, and internal injuries are the three types. Overhead and buried power lines at your site are hazardous because they carry high voltage. Examples of equipment and power lines are aluminum paint rollers, backhoes, concrete pumpers. Look for overhead power lines and buried line indicators with post-warning signs, and post-warning signs whenever necessary. 30% of approximately 350 electrical-related fatalities that occur each year involve cranes and overhead power lines. If contact occurs, proper safety precautions should be followed. The danger posed by overhead power lines at a construction are compounded by other factors. Here we can see a photo of an actual power line being touched by a crane. Use ground fault circuit interrupters or GFCIs on all 120 volt single phase, 15 and 20 ampere receptacles, or have an assured equipment grounding program. Follow the manufacturer's recommended testing procedures to ensure the GFCI is working properly. Ground all power supply systems, electrical systems, and electrical equipment. Frequently inspect electrical systems to ensure the path to ground is continuous. Visually inspect all electrical equipment before use. Take any defective equipment out of service. Never carry a tool by the cord. Never yank the cord to disconnect it from the receptacle. Avoid accidental starting. Do not hold fingers on the switch button while carrying a plugged-in tool. Disconnect tools when not in use before servicing and when changing accessories such as blades, bits, etc. Use of power cords on construction sites. Flexible extension cords often are necessary because they are exposed and unsecured. They are more susceptible to damage than is fixed wiring. Hazards are created when cords and cord-related and plug-connected equipment are improperly used and maintained. Grounding a tool or electrical system means intentionally creating a low-resistance path to earth. The term ground refers to a conductive body, usually the earth. System or service ground, in this case the type of ground, a wire called the neutral conductor is grounded at the transformer and again at the service entrance to the building. This is primarily designed to protect machines, tools, and insulation against damage. There are two kinds of grounds. Both are required under the OSHA construction standard. Equipment ground. This is intended to offer enhanced protection to the workers themselves. If a malfunction causes the metal frame of a tool to become energized, the equipment ground provides another path for the current to flow through the tool and to the ground. Using multi-receptacle boxes designed to be mounted by fitting them with a power cord and placing them on the ground, fabricating extension cords with Romex wire, using equipment outdoors labeled for use only in dry indoor locations, or using circuit breakers or fuses in a wrong rating with a wrong weight rating for overcurrent protection. Here we can see an incident of a crane contacting an overhead power line during freeway construction. The crane contacts the overhead power line during the freeway construction and 46,000 volts travel through the crane and beneath the concrete ground. Eyewitnesses to the accident state in a split second the whole crane, cab, and everything else explodes into flames. According to a fire chief, electricity will find its path, and if you're in that path, it will injure you. Hydraulic fluid and underground insulation become fuel for the flames, and slabs of concrete are lifted in the air. Debris rains down through smoke and fire, and the roadbed becomes fully engulfed. Fortunately, the crane operator escapes with only minor injuries by jumping from the cab. Handheld tools manufactured with non-metallic cases are called double insulated. If approved, they do not require grounding under the National Electrical Code. Although this design method reduces the risk of grounding deficiencies, a shock hazard can still exist. With the wide use of power tools on construction sites, flexible extension cords are often necessary. Hazards are created when the cords, cord connectors, and receptacles are improperly used and maintained. A GFCI is a circuit breaker designed to shut off electrical power in the event of a ground fault within 1/40th of a second. Here are types of GFCIs: receptacle types, portable types, and cord-connected types.